Class, welcome back. Next video on graphing with transformations. Alright, so we've covered all of the rigid transformations, the shifts, everything changing location, and then all of the reflections, which kind of change the orientation. Now we are moving on to vertical stretches and shrinks, which actually change the shape. Okay? So, things we need to keep in mind here, and things that are good to note. Vertical. This means y. And we know that all of our y transformations have to be, I'm not even going to say it because I've said it too much. I'm just going to write it. No, I have to say it. They have to be outside the function. Okay? So vertical stretches and shrinks, they're going to come from something happening outside of the function. What that is, think about if something's stretching. It's kind of, there's going to be like a factor to it. All right. Usually, if we stretch something, maybe we have to multiply. All right. So what I'm really trying to get at here is that we're looking for something being multiplied to the entire function. Alright, multiplied to the entire function. Now, what I want you to also keep in mind, and this is going to be more important for the next video, but it's a good thing just to kind of talk about now. Just like with y shifts, we said that if you have something being added after a function, then it's going to go up, right? The y shifts look exactly how they appear. It's the same thing with vertical stretches, okay? Same as it appears. Alright, now that might be kind of vague right now. Hopefully you'll understand what I mean in a second. Alright, so we're into it. We have an x squared. We know x squared, because we practiced yesterday, is over 1 up 1, over 1 up 3, over 1 up 5, or back 1 up 1, back 1 up 3, back 1 up 5. Alright, we sketch it. This is our parent function for x squared, and we know that we have this growth pattern, right? 1, 1, 1, 3, 1, 5, 1, 7, 1, 9. It can keep going on and on and on and on. All right? That's important for us to remember this. If we're not feeling good on this, memorize it now. Practice it, practice it, practice it. The reason we need to is because we are going to take our next function, f of 3x squared, and sorry, that's off a little bit. And we're going to realize that what's happening, we still have the x squared function, but we are multiplying a 3 outside the function. All right, now we just talked about it. Multiplying to the entire function, it's outside the function. It's exactly how it appears. This is a vertical stretch of 3, okay, because it's being multiplied by 3. What's really nice, guys, you don't have to go and plug in points. I just want you to use your growth pattern and understand that now, if our original pattern was 1, 3, 5, 7, 9, we have to multiply each piece by 3. So 3, 9, 15. We could keep going. I'm not going to be able to graph these, so I'm going to stop for right now. All right? So now when we go over 1, we're going up 3. Back 1 up 3. And now when we go over 1 again, we're going up 9. So this is up 7, maybe another 2, something like that, just to kind of give us some direction. All right, so what happens? Something like this. Okay, now what happened here? Hopefully you guys agree with me. This, well, I guess there's two ways to think about it. You could think that it got thinner, which is true. But more what I want you to think about right now is I stretched this original, like my parabola, that my original parent, I stretched it. Okay, I stretched it out. I gave it more height. So what happens now when we look at something like this? Ooh, 1/2. Hopefully you guys can kind of put this together. If I'm multiplying by 1/2, is it going to get bigger or smaller? Things are going to get smaller, right? So this is not a stretch. This is a shrink of 1/2. Now we do the same thing. We go back to our original growth pattern. This was 1. Well, now I'm going to multiply by 1/2. So 1/2, 3 halves, 5 halves, 7 halves, All right? What happens then? We're still just going over 1, so over 1 up half. Over 1 up 3 halves. Well, 3 halves is 1 1/2, so I'm going to go half and then a whole nother box. That's 1 1/2. And then it's 5 halves, so that's kind of like 2 1/2. Not kind of, it is 2 1/2. And then 7 halves is actually 3 1/2. So I'm going to go over 1 up half and then another 3 full boxes to make 3 1/2. And that should be good. All right, so something like that. Cool. And hopefully, again, you agree. I don't want you to think about this getting wider. I want you to think about my original, and it's getting kind of scrunched down. It's shrinking a little bit. All right? Now the last one, where we have to put a few things together. Let's think about this one. A few things are happening here. The very first thing we have to recognize is there's a negative, okay? And it's outside the function. So the first thing is reflect over x. Okay, reflect over x. Now, next thing, let's kind of figure out if we have to move or shift this at all. It looks like we do. It looks like we're going to go 1 up, right? Because we're adding 1 outside of the function. And lastly now, I consider this 2. This is going to be a vert stretch of 2. Okay? So let's think about this. I'm not going to look at my greens. I'm just going to go back to my original vertical growth. This was 1, so now it will be 2, because 1 times 2 is 2. 3 times 2 is 6. 5 times 2, 10. I could keep going, but I'm not going to be able to graph all these points, so you don't really need to. So we go and graph. We know when we reflect over the x-axis, I want to just consider that right now. I know that this is going to be, I can't do this with my hands, it's going to be flipped, right? We're going to be down here. It's going to open down. I know I have to go up 1. Now I use my growth pattern. I'm going over 1. I'm not going up 2. I'm going down the 2, right? Because it has to open down. I'm not going up 6. I'm going down the 6. So 1, 2, 3, 4, 5, 6. And then back 1 over down 6, sorry. All right, hopefully that makes sense. I want you guys to understand the reflecting part, you're not actually reflecting over the x-axis. You're just kind of flipping it so you know that the orientation is different. It's not opening up, it's opening down. Okay? And then you can sketch. Oh my gosh, I'm taking forever. Okay, let's get through this. Hopefully we're doing well on this. We have plenty more to practice. Let's see what's going on. All right, we have to work on our next function that we expect you to understand, which is our x cube or cube function. So we know over 1 up 1. Again, guys, this is coming right from the last video. All right, or plugging in values if you want to think about it like that. Okay, we know that this is our picture. We know that we can come up with our growth pattern. This one's the goofy one. It's 1, 1, 1, 7, 1, 19. Okay, it's kind of, there's nothing really special about it. It's just something that you kind of have to commit to memory or understand how I'm getting it. I'm just cubing. Like when I cube 1, I get 1. When I cube 2, I get 8. So what's the difference between 8 and 1? 7, etc. Okay? So, done with the black, move on to the purple. Ooh, we have another vertical stretch, right? This 2 is being multiplied outside of the function. So this is a vert stretch of 2. And we know what to do from the last one. We use our growth pattern to help us out. This is 2, this is 14, this would be 38. There's no way we're going to graph that, but good to know. We go over 1, we go up 2. We go back 1, we go down 2. If we wanted more, we'd have to go over 1, up 14. So that would be really high up here. So this one, guys, I don't even need any other points. I just need you to carefully sketch this cubic and understand what's happening. My original, that was already pretty skinny. When I stretch it more, it gets even more skinny. Okay? How about this next one? We got a couple things going on here. I definitely see a 1/4 being multiplied outside of the function, which is cubic. So this is going to be a vert shrink of 1/4. And how about this minus 6 inside the function? That's 6 to the right. Okay? So two things happening. Start by shifting, and now use your growth pattern. Get rid of these. We don't need those anymore. This is going to be the original multiplied by 1/4, or 1/4. 7 times 1/4 is 7/4. We could also write that as 1 3/4. 19 over 4. What's that one? What is that? 4 3/4? 4 3/4. Okay? So, again, do the very best you can. I know it might be hard to draw fourths, but again, do the best you can. Over 1 up a fourth. Over 1 up a fourth. Over another one, up 1 3/4. So the 3/4 is going to finish off this box, and then it'll go a full other box, something like that. And then let's do one more. 4 3/4 would be over 1, up 4, and about there. Back 1, 4 3/4. All right? And so we do what? We sketch with these points. What happened? Notice the original was right here. This one got wider, or really what happened is it got scrunched down a little bit. All right, one more. 3 things happening in this one as well. We have we're gonna go 5 to the left. We're going to go 3 up, and we are going to have a vertical stretch of 2. All right, so 5 left, 3 up. Let's do that first. Left 5, 3 up. Now what I'm going to do, guys, is I'm going to remember that my purple also had a vertical stretch of 2, so I'm going to use my same growth factor or growth pattern from the purple numbers that I wrote. So that means I'm going to go over 1, up 2, back 1, down 2. This 14, this one might actually be somewhat easy to graph going down, because this is 11, and then 12, 13, 14, so something like that. So now we can get a little bit better idea of what this one would look like. So something similar to that. All right? Okay, how are we feeling? Hopefully we're doing okay with this so far. Again, what is it? Determine what the transformation is, and if you have a stretch, you just change the growth factor. All right, next page, we have 2 more functions that we need to practice on. One is absolute value, so we'll start with that. We know that our absolute value is going to do one of these, and something like this. And the growth pattern's super nice, right? We know it's just horizontal, vertical, 1 1 1 1 1 1 1 1, etc., etc., etc. Okay, so we're done with the first part. Let's move on to some transformations. Well, I have a 5 being multiplied outside the function, which means this is a vertical stretch of 5. So what do? Well, I change all of my vertical growth patterns to 5. So now when I go over 1, I'm going up 5, over 1 up 5, or back 1 up 5, 5. And so now I know what that will look like. All right, not too bad. Switch to my next one. Hopefully we're feeling better with these. We're getting the hang of it. We know that there's going to be a vertical shrink of half, and this minus 5 inside the function means I'm going 5 to the right. So I start by going 5 to the right, and then we think, I'm not doing the 5s anymore. My vertical shrink was half, so I multiply by half, so half, etc., etc., right? So I'm going to go over 1 up half, over 1 up half, 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 half. I could keep going right other way. Half, 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 half. Did I mess that up? I don't think I did. Did I? Whatever, we'll see. So we graph it. Something like that, and like that. All right, what did it do? It squished down. That's what we wanted. That's what we thought would happen. All right, nice. All right, last one here. Oh, we got a lot of stuff going on. I think we have 4 this time. We definitely see a negative outside of the function, so we know this will reflect over x, or what does that really mean? It's going to have opposite orientation, or the orientation is going to be pointed down, opening down. What else do I have? I have a vert stretch of 3. I have a 3 to the left, and I have a 3 down, right? Negative, reflect. This 3, vert stretch. This positive 3 to the left, this minus or negative 3, 3 down. So now we just have to put it all together. And we start with the idea first, you know it's going to be opening the other way. Then you think about the shift of the vertex here. I'm going 3 to the left, I'm going 3 down. Lastly, I consider my stretches. My stretch is 3. So this is not half, this is 1 times 3, so 3, 3, 3, etc. Please remember, I'm not having you, I'm trying to keep it very, I don't want to say bland, I'm keeping it vague on purpose here. You can use this in multiple ways. You have to remember, and you have to be smart enough to understand that if I'm reflecting over x, I mean I'm going down 3, right? So over 1, down 3, back 1, down 3, over 1, down 3 again, back 1, down 3 again. And now I have my graph. All right. Oh my goodness, this video is running a little longer than I wanted to, but actually for me, it's not too bad. Not too bad. All right, let's see what's going on in this one. What's going on in this one? Okay, so square root. If you don't remember, we plug in nice x values. So we can plug in a 1, we get a 1. If we plug in 4, we get 2. We plug in 9, we get 3. And what I really care about from that is the growth pattern. Okay, horizontal, vertical, which you can hopefully remember here, it's the inverse of the square. So now our vert are going to be the 1s, and the horizontals are going to be the 1, the 3, the 5, the 7, the 9. Okay? Cool. Hopefully we're getting the hang of that. Let's try a couple. Well, 2 being multiplied outside of the function. Vert stretch of 2. So you take your vertical values, right? Y, this is still a vertical stretch, so it's still affecting the y values, and these all become 2. All right? So what does that look like? Well, now we're going over 1 up 2. Over 3 up 2. Over 5 up 2. What did it do? It stretched it vertically. Perfect. That's exactly what we thought would happen. All right. How about the next one? Ooh, we know this one. We've seen this already. This is a vertical shrink. And it's half, right? All right. So now instead of 2, 2, 2, 2, it's half, 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 etc. So we go over 1, we go up half. We go over 3, we go up half. We go over 5, we go up half. And this, again, does exactly what we thought it would do, right? We thought it would shrink it. It did. It smushed it vertically. That's what we wanted. All right, the last one for this video. Please be very careful here. The way this is written is not okay. All right? If you remember correctly, we always need to have a positive 1 coefficient on the x. And again, normally I always like to write things closer to standard form, so x's should come before constants. So let's rewrite this and see what's going on. Negative 3. Okay, so the first thing is this, negative x plus 2. I rearrange it a little bit. Now here's what I'm talking about. Right now, the way this is written, I do not have a coefficient of positive 1. I have a negative 1. Okay? That's not okay for right now. That's not okay. So we're going to rewrite this even more. Negative 3. I'm going to factor out whatever that value is, so it's negative 1, which now leaves me with a positive 1 coefficient, but now I have a minus 2. Okay? A negative 2. Now we're ready to go. Now we can see all of our transformations. I definitely see 1, 2, 3. Okay, so I see 4 things happening. I see a negative on the outside, which means I know I'm going to reflect over x. One thing I also have here, and this is probably, I hope I didn't confuse you here. Shoot. Let me rewrite this. I'm sorry, guys. Negative 1, I'm just going to write it as a negative. Okay? I do not want to confuse you. I want you to see this. There's a negative inside the function. And if there's a negative inside the function, then I know I also have to reflect over the y-axis. Now again, please, if this, hopefully this is okay to you. Hopefully you guys are smart enough algebra students. Negative 1, it's the same thing as a negative. So if you were here, this should be okay. But again, if I did confuse you, just understand that a negative 1 is the same thing as just a negative. All right. Now let's see, what else? Ooh, a 3 outside. This is a vert stretch of 3. And lastly, I see a negative 2 inside the function, or a minus 2 inside the function. So 2 to the right. All right. So again, 1 and 2 are the concepts, the ideas. I now know, because I'm reflecting over the x and I'm reflecting over the y, my function is going to have to go down and to the left. Again, one more time. Reflecting over the x would mean I would go down and to the right. But because it's also reflected over y, I'm going down and to the left. All right? I have a shift 2 units to the right. And I know that my stretch is 3. So 3, 3, 3, 3, etc. Okay? Good. Now, remember, we're going down and to the left because of the reflections. So as I move over 1, I'm moving over 1 to the left, and I'm going down 3. And now I'm moving over 3 to the left, and again down 3. And the last one here that I can graph, I can go over 5 to the left, down 3. And I sketch a curve, and that is our 4th function. All right, so again, what did we do today? We worked on graphing parabolas, cubics, absolute values, square root functions, point by point, right? We get point by point because of our growth patterns, but now we're incorporating vertical stretches and shrinks. Have a good day.